Hi everyone, this is going to be a walkthrough video for question 5, add only list on CS61B Fall 2020 Midterm 1. Let's get started. So it says, before starting this problem, we can use previous parts. Okay, we'll keep that in mind. Suppose we define a new AddOnlyList class as follows. Okay, so we're creating this AddOnlyList class, and we see here that we have to implement these 4 methods, and we have access to instance attributes, items, and size, and we have a constructor, which kind of looks similar to the array deck to me. Okay, it says instead of treating the array like a circle like you did in array deck, the AddOnlyList uses an outward in pattern to store its items, as shown in the figure below. Okay, so it seems kind of weird. Let's see what's happening. For an items array of size 8, item 0 goes in the list in index 0. Okay, so what that is saying is that item 0, okay, my pen is not working for a sec. Item 0 goes here, okay? Then we see that item 1 should go in index 7, okay? So, perfect. Okay, item 1 goes in index 7, sorry about that. Item 2 goes in index 1, right? And then we see here that item 3 goes in index 6, and so on, okay? So it's kind of jumping back and forth from either end of the list and growing it out as such, okay? So let's keep reading this. Fill in the functions index of I, get, add last, and resize, okay? Index of I gives the position of the ith element if the size array is of length m, okay? For example, if I is equal to 3 and m is equal to 8, index of I of 3 and 8 is equal to 6, okay? Note that item 3, D, is in position 6 in the figure above, okay? You may assume that m is a power of 2 that is greater than or equal to 8. Okay, so we have to implement index of I, get, add last, and resize. And get, add last, and resize should have similar definitions as the project, so we don't need an explanation, but index of I is new. And I'll try to give a little more explanation than what's happening here, okay? So looking at the code, let's first pull up some example. Okay, so let's say we have this array. So we have indices 0, 1, 2, 3, 4, 5, 6, 7. Okay, and what's going to happen is that these are our indices, but our items aren't going in this order, right? If you remember in the example above, I'm going to say our items, right? Item 0 goes here, item 1 goes here, item 2, 3, 4, 5, 6, 7. Okay, so the items go in different places than the indices. Okay, so all index of I is asking is taking in an int I, which we can think of as an item, right? It's going to be one of these values up here. Okay, so it takes in an item number and it wants the index where that item is. Okay, so the example was index of I that takes in item 3, right? And m is equal to 8, where m is the length of our array, will give us 6 because item 3 is at index 6, okay? So we can kind of think about it as we take in an item number and we have to spit out the proper index number, okay? So what relationship is there between item numbers and indices? Well, the first thing that I noticed, it took me a while too, so I didn't notice immediately, is if we look at the even numbers, that each even item number, when we divide it by 2, we get the appropriate index number, okay? So what we can say here is that if I mod 2, that's not 2, is equal to 0, in other words, if I is even, if it's an even item number, then all we have to do is return I divided by 2 to get its proper index number, okay? So this is the even case, and we've dealt with it, okay? Now all we have to do is deal with the odd case. So if we take in an odd number, it's not as intuitive where the proper index number is, right? Like if we give in 3, how in the world do we get to 6? Okay, so to get to this solution, it's a lot of just like trying out different possibilities, like guess and checking. But one cool like jump that I think is reasonable to make is if you use I divided by 2 in the even case, you maybe should use I divided by 2 in the odd case, because there's like a symmetry happening here, right? It looks kind of symmetric, but we're growing from the odd numbers from left to right. So my idea is, since we're growing in this direction, we can say m minus I divided by 2, and this hopefully will give us the odd numbers, okay? But this is my guess. This is my first guess, okay? So we see here that if we look at 1, if I do 8 minus 1 divided by 2, that will give us 8. If we look at 3, we say 8 minus 3 over 2 will give us 7. So if we compare these numbers, right, we should notice that we're only off by 1, right? So our final answer is we just subtract an extra 1 here, okay? And that is the odd case. Brilliant. So m minus I. Nice. Okay. So that is index of I. I'm going to get rid of the work. Oh, that's sad. Okay. So let's look at get. What get is saying, get takes in an item number, right? We're getting the ith item, and we should give its value, right? So if we call get on, I don't know, 1, what should happen here is we have this underlying items array. Okay, I made it too big. That's my bad. Let me resize. Okay, so we have this items array, right, which has 8 elements. What get of 1 should do is it should go to the correct, okay, my iPad, right? Get of 1 should go here and extract the element from there, because item 1 is actually in index 7, and we can just return whatever is at this spot, okay? So to do that, we can use index of I, which we implemented in the previous part, and simply index items at that spot, right? I, and what should m be? M is the length, so we'll say items.length. Okay, a common mistake was putting size here, right? M, as you guys know, should be items.length, because otherwise this won't work. Okay, nice. So the next thing we want to do is add last. Okay, so let's say that we have a current state of, let's see if we can get rid of the yellow. Nice. Okay, let's say that so far we've added the letters A, B, C, and let's say A went here, then B, then C. Okay, and now let's say that we want to do add last on D. Okay, so we know that D should go right here. Okay, so how do we know which index to get? Okay, well, if we think about D, D's index, right, or D, I take this back, D will be item 4 in our array. 0, 1, 2, I take that back. D will be item 3. My bad. D will be item 3 in our array, okay? So what we can do is we can call index of I, right, on 3 and 8, which will give us 6. Then we can index items at spot 6 and change what's there to be X, okay? Well, how did we get this number 3? Well, 3 is the current size of our array, okay? So all we're really doing, I'll get to this logic afterwards, is we go to the items array at index of I, where size is going to be X's index, right? So we go to X's item number. I take that back. So we say index of I on size on items.length, and this will give us, right, that's this spot right here, which we're setting equal to X, okay? Just for one more explanation, in order to add last on X, we know that X is item number size, right? So what we can do is call index of I on size and items.length, which will give the index that X should be inserted in the list. Then we go to items, index it at this return value, and then we put X there. And the only thing we need in the body after the if statement is to increase the size. Okay. The one thing we did forget, however, is what should we do here? So if you guys remember, if we cannot add any more elements, we should resize. We can't add any more elements when the size is equal to items.length, in which case we should double the capacity. So we can do that. Nice. Size would also be fine here. Either one would work. Okay. So the last thing that we need to do is resize. What resize should do is, I'm going to say, take a smaller example. Let's say that we have a 4 element. Okay, let's say it goes A, B, C, and D. What resize should do, it should double the length, right? It doubles the length, and it should move A here, it should move B here, C, and D. Okay, so that's what resize operation should do. Okay, so there's a couple ways of solving this. One way is we can call array copy and move AC here, and call array copy and move DB here. Okay, but personally, I'm not a huge fan of array copy because there's always like off by 1 errors, and there's too many arguments in that function. So we're going to do a different approach very similar to the ArrayDec resize function that went over in the staff solution in the lab. Okay, so what we're going to say is we're going to iterate through. Okay, we're going to iterate from I equals 0, I is less than size, I plus plus. Okay, now what we're going to say is we're going to get item number 0 and put it in this right spot. Okay, we're going to get item 1, put it at the right spot, get item 2, put it at the right spot. Okay, so we're going to find, we don't know the correct, we do know the correct spot, but here's like the skeleton. Okay, we're going to go from 0 all the way up till size. We'll get that element using our get function, and we should put it at the correct size in new items, right? So what that means is, what we should do, we'll start as I is equal to 0. When I is equal to 0, we'll get 0, which will give us A. Then we should put A here. Then I will become 1. We'll get B, and somehow we'll need to know to put B here. Then I will become 2. We will get C, and we'll put C here. Okay, that's my idea. And we can just do this up till size. So what's the correct index to put things at? Well, we have the index of I function, right? We can just call it on I, except the length of the new array that we're inserting is new len, right? Which should also go up here. Okay, so this is the solution for resize. Thank you guys for hanging in with me. I know this was a long problem, but yeah,